A binomial distribution is as a result of a binomial experiment. So let me give you an example of a binomial experiment. So let's assume you go to the basketball court and you want to make some free throws. When you decide to make this throw, it's either you make the basket or you don't make the basket. The experiment in this case of ours is the fact that you are trying to make a free throw, and the outcome as a result of making this free throw is actually making the basket, which is the success of the experiment, and not making the basket, which is the failure of the experiment. The Bernoulli experiment is performed just once, and the outcome of this experiment has just two outcomes: success and failure. In this case of ours, making the basket and not making the basket. A binomial experiment is a Bernoulli experiment that was performed n number of times, meaning you perform the experiment at least 2 times. So if we decide to make 2 throws, 3 throws, 4 throws, 5 throws, as much as possible down to let's say 50, then we have a binomial experiment. So the distribution that defines such experiments in this case of ours is actually known as a binomial distribution. So let's assume you decide to make 10 throws. So what is the probability that you're going to be making a basket in like 8 of these throws? So that is at n is equals to 1 down to n is equals to 10. What is the chance that you're going to be making successful 8 throws? This question can actually be answered by using the concept of binomial experiment. Welcome to another video, and in today's video we are going to be talking about the concept of the binomial distribution. Without further ado, let's start learning properly. Now, the binomial experiment or the binomial distribution has a few properties that is actually or almost similar to that of the Bernoulli, in the sense that the experiment actually has 2 outcomes, and that is success and failure. We also need to understand the fact that for each of the events of a binomial experiment, the events are actually independent on each other. By independent events, I mean the occurrence of one of the events does not affect the other. That is, the chance that I am going to make a successful throw right now in my first throw does not affect the chance that I am going to be making a successful throw in the 3rd, 4th, 5th throws. If you need a video about the concept of independent events, I would be linking a video in the top right corner, so you can just go check that out. So just like a Bernoulli experiment, a binomial experiment is actually a type of a discrete probability distribution. So that simply means that it has formulas for the expected value, the variance, and the standard deviation. So let's go into this formula one bit at a time. So the formula for the expected value of a binomial experiment or a binomial distribution is E of x, which is the expected value, is equals to the number of times the experiment was performed times the probability of success. So that is E of x is equals to NP. The formula for the variance is actually equals to N times P times 1 minus P. Like I said earlier on, the P is the probability of success and 1 minus P is actually the probability of failure. And the formula for the standard deviation is actually the square root of the variance. A binomial distribution is a typical example of a discrete probability distribution, which simply implies that it has what we call a probability mass function. Now, the probability mass function that actually defines a binomial distribution is given as P into brackets x is equals to R is equals to n combination R times P raised to the power of R times 1 minus P raised to the power of n minus R, where n represents the number of times that the experiment was performed. In this case of R, the number of throws that I make. P is the probability of success, which is the probability of me making a basket successful. 1 minus P is the probability of failure, that is the chance that I won't make a basket. And R is actually a fraction of n, meaning if I'm going to be making 10 throws in total, what is the chance that I'll be making 8 successful throws? So that is n is equals to 10 and R is actually equals to 8. Please note that in every case R must actually be lesser than or equals to 10. So let's go back to the example of me making a free throw. So let's assume based on my skill I have a 60% chance of making a successful throw, making a basket. So I decide to make 10 throws. What is the chance that I will be making 8 successful throws? So in this case of ours, our n is equals to 10, our P is equals to 60%, which is actually 0.6. So that means that the probability of failure, which is 1 minus P, is equals to 0.4. And then the question says, what is the chance that I'll be making 8 successful throws? That is P into brackets x is equals to 8. I'm going to be using the probability mass function to get the probabilistic value attached to each of the events of the experiment. So that is what this formula is basically for us to calculate the probability of each of the events of a binomial experiment. So probability that x is equals to 8 is going to be equals to 10 combination 8 times 0.6 raised to the power of 8 times 0.4 raised to the power of 10 minus 8. And when we do the math with our calculator, we have the answer to be 0.1 0.1209. So the chance that I'll be making 8 successful throws in a total of 10 throws is actually going to be 0.1209. We can also decide to tweak the question a bit and start asking questions like, what is the probability that I'll be making at least 4 throws? That is probability that x is greater than or equals to 4, which is actually equals to probability that x is equals to 4 plus probability that x is equals to 5 down to probability that x is equals to 10. So we are going to be calculating the probabilistic value for x equals to 4, x equals to 5 down to 10, and then we are going to be summing them all. Trying to sum probabilities in a binomial experiment can actually take a whole lot of time, so that is why we have cumulative probability tables, or we have softwares that can actually help us to calculate the cumulative probabilities. So I have this software that I used to use. So to answer the question of probability that x is greater than or equals to 4, all I have to do is to substitute the value of the p, which is 0.6 in this case, the value of n, substitute the value of r also, and this calculator is going to give me the value of probability that x is actually greater than or equals to 4. We can also use Excel to get the cumulative probabilities attached to binomial experiments and any other software such as SPSS or RStat or MATLAB. So for this example of ours, the expected value of those experiments is that E is equals to n times P. Our n is equals to 10 and our P is equals to 0.6. So the expected value is equals to 10 times 0.6, and that gives us 6. So the interpretation of the expected value is that I am expected to successfully make 6 baskets out of a total throw of 10 throws. Since a binomial distribution is actually a typical example of a discrete probability distribution, it simply implies that if we want to visualize this experiment of ours, we are going to be using a bar chart. So to visualize this experiment of ours, we are going to be getting probability that x is equals to 0, probability that x is equals to 1, down to probability that x is equals to 10. Then we are going to be plotting the value of the random variables, that is x is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis, and we'll plot the value of the probabilistic value on the y-axis. And then when we do that, we are going to be having an outcome that looks like this. So this graph right here is what we'll call the binomial probability distribution, and the mathematical function that actually helps us to calculate individual probabilistic value attached to each of the events of this experiment is actually known as the probability mass function. If you learned something new from this video and you actually enjoyed this video, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel. Thanks for making it to the end of this video, and we'll see you in the next one. So bye for now.